We got true. 2. Yes, 2 is less than 3. True. 3. 3 is not less than 2. 3. 3 is equal to 3. So that is the reason we got. Okay. Now, I don't want to get this true, true, false, false, false and all. So I want to get those particular numbers which are less than value. That is 3. Then what is the piece of code you have to use? You have to use this piece of code. Underscore ARR of the condition. What is the condition? A underscore ARR less than val. Now check it. See, we'll get those values which are less than the value. Okay, so that is what to get. Next, NP dot linspace 1 comma 10 comma 50. Okay, what is this? What is this linspace? So linspace. Do remember these words, guys. These terminologies. These are very important. So when I say linspace 1 comma 10 comma 50, what we will get is we will get the numbers. We will get the numbers. What type of numbers? A random numbers between 1 to 10. How many numbers we will get? We will get 50 random numbers. So if you count all these things, these are 50. And all these numbers are between 1 to 10 only. So here 1 is there, here 10 is there. All the numbers are between 1 to 10. Okay, so this is what linspace is. So why we use this linspace for normal distribution, binomial distribution, certain mathematical concepts we use. Suppose if I want to get 1 to 10, I want to get random numbers between 1 to 5. How many I want to get? I want to get 15 randoms. Okay, see. And if you observe one thing, you need to observe this one, the lower boundary will be included. 5, the upper boundary will be included. Okay, so this is what linspace is. Next. So again, we have something called as random dot rand 3 comma 3. So what is this random dot rand? So random dot rand 3 comma 3 means, guys, you will get a random number. Any random number which will be less greater than 0 and less than 1. So if you see all these numbers here are less greater than 0 and less than 1. That is 3 comma 3 means 3 rows and 3 columns. So we got 3 columns as well as 3 rows. So even this is also used for mathematical concepts. So do remember random dot rand. Next. So we have seen how to create an array. Now let us see how to create a matrix. So how to create a matrix. So for that, what I will do, I will create a list. LST equal to. So let us have elements 4, 5, 6, 7. And that's LST. This is list. It consists of elements 4, 5, 6, 7. Now, so let us convert this list into a matrix, and I am naming it as mat. Okay, so let us change here, make it as LST. So if you observe here the same code, guys, if you see here, go here, go here, go here. So here, keep it all here. If you observe, when I am converting underscore list into an array, what is the code I had used? NUMPY.array. So when I converting this list into a matrix, what I'm using np.matrix. Okay, and I'm naming it as mat. So let us remove this one and let us run this mat. Right? See, this is matrix. The same thing I'm running. Which one? Underscore ARR, which is made from underscore list. Underscore ARR. Correct. Okay. So this is underscore ARR. It is made from underscore list. So let us check how underscore list looks like. LST look like. See, this is how underscore list look like. If you observe here, what one thing you need to observe carefully, guys. I have taken this list, listen carefully. I have taken this underscore list. So this is underscore list, which is a one-dimensional one. I convert it into an array. Okay. So this is the output. Fine. So how many square brackets are there? Only one square bracket. Now the same thing, what I'm doing, I have a list. List consists of elements 4, comma 5, comma 6, comma 7, comma 8. Even it is one dimensional. So what I'm doing, I'm taking this list and I'm converting into a matrix. And when I run that one, this is the output. So if you see in this output, there are two square brackets. So what is the thing you need to identify? So even if you convert a single dimensional list, it will, when converted into a matrix, it will automatically convert it into a two-dimensional matrix. So matrix, you cannot have one dimensional or multi-dimensional. You can have only matrix two-dimensional, but an array can be one-dimensional, two-dimensional, three-dimensional. So this point is very important point. Okay, anyway, we had created one matrix. So let us ask for type of ARR. So type of mat. I'm asking for type of mat. Right. See what it is saying? NUMPY dot matrix. If you ask for type of underscore ARR. Right. So what it is saying? It is saying ND array, n dimensional. Here it is not saying ND matrix and all. The reason is matrix will be always two-dimensional. Remember this point. Next. So we have something called as horizontal append and vertical append. Okay, let me rename it as mat one. So I am taking this list with elements 1, 2, 3, and I am making it as mat 1. So that is mat 1. Now let me take another list. So this is another list with elements 4, comma 5, comma 6, and I am naming it as mat 2. Mat 2. Okay, so if you see here, we have two matrices. Mat 1 is this, mat 2 is this. Now what we are doing is horizontal append. Horizontal. Okay. Change their names. See, we are doing horizontal append. When we did a horizontal append, how these matrices has come? 1, 2, 3. Okay, here. And 4, 5, 6. So horizontal append, it will do horizontal. A sleeping layer. Okay. We can do vertical append also. Okay, if you do vertical append, we will get vertically. Mat. Correct. So we got vertical. One above the other. 1, 2, 3, and then down 4, 5, 6. So how Python knows that it has to do horizontal append and it has to do vertical append? By this piece of code. What is that piece of code? np.hstack. Hstack stands for horizontal stack. np.vstack. Vstack stands for vertical stack. Then it will do vertical and horizontal. And do remember, guys, for horizontal stack, for example, what I'm doing is, if you observe here, see carefully. Mat 1 consists of 3 elements. Mat 2 consists of 3 elements. Now what I'm doing, I'm changing this mat 2 into 4 elements. Okay, so make it 7. I'm adding another 7. I'm running that one. So this is mat 2 now. It consists of elements 4, 5, 6, 7. Now if you try to do vertical stack, horizontal stack, yes, we got the result. And now try to do vertical stack, right? See, it will throw error. So what is the reason for vertical stack? Always the number of elements should be the same. Then only you can do vertical stack. Otherwise, you can't do vertical stack. Fine. This is one more thing to remember. Now, come here. List one. List one. So what type of list this is? What type of list this is?
Two
Nested
dimensional.
list.
Nested list, guest. List will not be two-dimensional. Do remember, it will be nested. That's it. Okay. So this is a nested list. Got it? This is a nested list. Now what I'm doing, I'm making this nested list into a two-dimensional array. So array can be two-dimensional. Fine. Correct. See, this is what. See, guys, when you run this list, this is the output. When you run this array, which is converted from this list, this is the output. So this is two-dimensional. It has rows and columns. Okay. So now, if you observe this array array 2D, we had made from list one. This is what the output we have. Now let us do certain things with this ARR 2D. Now ARR 2DF. ARR 2DF. See here, observe carefully, guys. When we have converted this list of elements into an array, this is the output we are getting. 1, 2, 3, 4, 5, 6, and all. No, I don't want 1, 2, 3, 4, and all. I want them in decimal levels. I want them in decimals. So how to use? Just see, this is the code. Just to that code, add something called as data type equal to D type equal to float. Now it will be converted into decimal. See here. We got 1 point, 2 point, 3 point, and all. Right? Next. You can convert them into string also. You can convert that one into string also. Now what I am doing, I am creating another array with the name ARR2DF, and I am specifically saying data type equal to float. See here, specifically saying data type 1.2. So this floating I can convert into integer, and again I can convert into string also. See here, for example, if I run this piece of code, integer. See, previously it was decimal, everything. I had converted into integer. And after converting it into integer, I can convert into string also. Right? See. So how can you say this is a string? How can you say this is a string?
Double brackets.
Enclosed in
Double
the
quotations,
single
so
bracket.
single quotations. So anything within single or double quotation is string. So everything, every element got has changed into a string. Okay, so how to do that one? As type, just string, str. Okay, next. You can make into Boolean also. You can get a Boolean array. Suppose if you see here elements, you have elements here 1, comma 0, comma 5, comma 0, comma 0. Type equal to bool. So wherever there is number, it will show true. Wherever there is 0, it has to show false. See, wherever there is a number, what it is doing, it is showing a true, and wherever there is not a number, it is showing a false. So you can convert into a Boolean also. Next. List 3. Correct. So this is list 3. It consists of these elements. So it is a nesting list. Now let us convert this into a 3, and I'm specifically saying data type equal to float. So what happened? Every number will come in a form of decimal. This is the thing. Now print ARR3 dot shape. So we got the shape 3 comma 4. That means 3 rows and 4 columns. So dot shape will give you the shape. Remember all these methodologies. Print data type of ARR3 dot data type. Suppose if you want to know what type of data type you are working with, data ARR3 dot data type. So use data type. So it is a float. So it has to say float. Okay. Next. Size ARR3 dot size. So it will give the size. Size is 12. So what is size? Number of elements. So here how many elements are there? 3 rows and 4 columns, which 12 elements. So dot size will give you that size. 12 elements. Okay. So print number of dimensions. How to get ARR3 ending. Ending means number of dimensions. So how many dimensions are there? 2 dimensions. Okay. So you have to get 2 as the result. See, dimensions are 2. Next. ARR 3 colon 2 comma colon 2. So this is interesting. This is what the main thing is. ARR 3, which is ARR 3 colon 2 comma colon. You please answer, because when we covered this R language, I had told you how to slice a 2-dimensional. Can anyone answer this question? Please type in the chat. So this is slicing a 2-dimensional. You want me to explain this concept? So how to slice a 2-dimensional? You want me to explain these concepts, or can you answer? All are silent. That means you want me to explain. Okay, fine. So come here. Let us see how. Pardon?
Explain, sir. It takes 2 rows, takes the first 2 rows, index 0 and 1, and 2 columns, takes the first 2 columns, index 0 and 1.
So which elements will get Nikita?
1, 2, 3, 4.
Okay, very good. Fine. Let me explain you. See, what is this? 1, 3, 3. All listen carefully, guys. 2, 4, 6, 3, 5, 7, 4, 9, 8. Okay. So what is the index? What is the index? Index. This is row index. 0, 1, 2. What is the column index? So this is the column index. 0, 1, 2, 3. Okay. So what we had asked, column 2, comma, column 2. Okay. So if you see here, this part, this is left hand side part, this is right hand side. So left hand side part deals with rows. Right hand side part deals with columns. So what is rows related to column 2? So that means column 2 means here nothing is mentioned. If nothing is mentioned, what is the meaning? Give me from starting row. 0. So right hand side, what you have to do? You have to do a -1. So 2 minus 1, that is 1. So that means 0 index row and 1 index row elements. So column wise also column 2. Column 2 means nothing is mentioned here. There is a 2. That means give me from 0 index column 2. Here 2 is there. You have to do a -1. 2 minus 1. That is 1. 1. So 0 index column, 1 index column, 0 index row, 1 index row. So you see this part and this part. Sorry, this part. So finally, what is the combination? This 1, 2, 3, 4. So what we have to get? We have to get this 1, 2, 3, 4 outside. This slicing is very important. Please do practice this slicing. Because in real term, we will do a lot of time this slicing activity. Very often we do. That is the reason. Why? So let's see, we got 1, 2, 3, 4. Okay. List 3 colon 2 comma colon. So this is list 3. So for this list 3 colon 2 comma colon. Okay, run it. See, it will not. Because this is not a two-dimensional structure. That is the reason. Fine. Next. Just now what we had seen ARR3, right? Let me run ARR3. Right? So this is ARR. So now ARR3 2 comma 1 equal to NP dot NAN. So NAN, what is NAN? It is not a number. NAN means it is not a number, it is nothing. NAN. So why we use in machine learning models and all, sometimes we make something as NAN and all for mathematical calculations and all. So you will come to know about in the coming up classes. So NP.NAN. So ARR3 2 comma 1. So what is 2 comma 1 guys? Which element is 2 comma 1? See, this deals with
Six, sir.
columns. This
6.0.
deals with rows. This one. So 0 index, 1 index, 2 index, 0 index, 1 index, 2 index, 3 index. So 2 index row. So this row. 1 index column, this column. So what is the element? 6. So
sir.
this 6, what we are trying to do, we are trying to make as NAF. Okay. So yeah, the 3, right? See, that 6 became NAF. Now ARR 3 of 1 comma 2 equal to NP dot infinity. So which element will become infinity? INF means infinity. Which element will become infinity?
Five, sir.
Element
9 will be. Huh?
3, sir.
3, sir.
So Python is 0 based index, not 1 based index.
5, sir.
5,
Five, sir.
5, sir.
So you
Five,
have
sir.
to get this
Five, sir.
5. So that 5 will become infinite. So you have 3, that is done. So that 5 become infinite. Okay. Now, missing values. Missing values. So what are the missing values? INF is a missing value. NAN is a missing value. So what I want to find out, NP dot is NAN or NP dot is infinity of array 3 and I am naming it as missing values. Let us run that one. See, wherever there is a missing value, we get to see here infinity is there in missing value. Here infinity in NAN is there, is a missing. Okay. So if you want to get those particular, what you have to use, you can use. There are 3 got missing of missing values. See, what are those? Infinity and missing values. Now, ARR3 of missing values equal to -1. See, ARR3 of missing values equal to -1. So what is happening here? What I am doing in this piece of code?
You are assigning a -1 to the all the missing values, sir.
We are assigning a value of -1 to the missing value. So wherever missing value is there, we are assigning a -1. Correct. See. Fine, you should understand code, guys, everyone. That is the reason why, see, theoretically, I can just simply say all the things, but why I'm practically explaining because programming is always practical thing. Fine, so I'm making you familiar with the code. Try to understand and try to practice all these things. I will share you the code as well as today in the Word document and practice them. Next, print mean value. So suppose this is ARR3. What is it? ARR3. This is ARR3. So I want the mean of this array. So how to get ARR3 dot mean will get you the mean. So mean means sum of total number of elements by number of elements. So that is 3.5. So not only that, you can get max value also. Suppose in this ARR3, I want to get maximum value. What is the maximum value? Here 9 is the maximum. Right? See, 9. You can get minimum value also. What is the minimum value? -1 is the minimum value. So in ARR3 dot min, you will get minimum value. That is -1.0. Fine. And next, ARR3. Right? So this is ARR3. Now, not only ARR3 wise, you can get row wise maximum and minimum. You can get column wise maximum and minimum also. So how to get row wise, column maximum and minimum and row wise? So print column wise minimum, column wise minimum number. NP dot aim in ARR3 axis equal to 0. Do you remember, guys? The axis equal to 0 represents columns, axis equal to 1 represents rows. So we'll get column wise minimum number. If you see in this column, 1 is the minimum number, in this column, -1 is the minimum number, in this column, -1, and in this column, 4. So we have to get column wise. See. So not only column wise, you can get row wise also. For example, I'm actually going to row. Here axis equal to 0, I will make it axis equal to 1. So right. See. So row wise here, this is 1 is minimum here. This is -1 is minimum, this is -1. So we can get row wise as well as column wise. So these things we will do lot of this, lot of time. Okay. Next. Print ARR3. So this is ARR3. Now ARR3A, ARR of column to column. So what is happening? What is ARR column 2, column 2? So these elements. What are the elements? 1, 2, 3, 4. So what I'm doing, I'm making this 1, 2, 3, 4 into a separate array and I'm naming it as ARR3. That means we are creating a child array. We are creating a child array from this parent array. Okay. So run it. ARR 1, 1, 2, 3, 4. Okay, so this is what we call. Fine. So anyway, guys, we shall continue our journey in the next session. Let me stop recording.